geometry for simulation, the first thing I will do is apply or change the desired materials based on the desired physics setup. By default, structural steel has been applied to everything in the model. In Discovery, the structural steel is the default material for all the solid bodies and water for fluid flow problems. To change the material, go to the Simulation tab and select Materials. To assign the material to a body, click on the body and assign the material from the drop-down menu as needed. Here I am applying air for the fluid volume. You can also change your material quickly by double-clicking on the material and then changing it directly from the physics tray. In Discovery, you can also create your own user-defined materials. To do so, go to the Material drop-down menu and type User-defined fluids. Then change the relevant properties in the drop-down menu, and you can then save the material to your local library and assign a name to it. You can use the saved material for your future simulations also. Let's stick to air for this case. Once we are done with the material assignment, we can jump to the physics setup. To set up the physics, go to the Simulation tab in the top ribbon and choose Fluid Flow as our desired physics. If you are unsure about the meaning of these different small icons, you can access our comprehensive overlay help system by hitting F1 on your keyboard or clicking on the question mark icon at the top right corner. Our context-sensitive overlay help system will display the meaning of these icons as you hover your mouse over them. If you select the flow inlet boundary condition, it will also show you a small video on how to apply the flow inlet boundary condition. There are also other information like how to apply these boundary conditions in a step-by-step manner, so whenever you are not sure about anything at any point, please feel free to use our comprehensive overlay help system. On the left side of the heads-up display or HUD, you will find different fluid flow physics conditions like rotating flow, porous, wall, fan, and flow. Since we have chosen flow, from this drop-down menu, we can choose inlet or outlet. Let's select inlet. On the right side of the heads-up display, we have different input options like velocity, mass flow rate, pressure, or swirling flow. For this case, we are choosing mass flow rate. To enter the value of mass flow rate, we are going to enter it in the inputs. For this case, we are applying the mass flow rate of 0.01 kg per second. Finally, hit the check mark or press enter on your keyboard to apply the changes. Let's apply mass flow inlets for other phases too. Similarly, to apply flow outlet boundary condition on the front vents outlet, select one phase at a time, and from the fluid flow boundary condition, select flow outlet and enter 0 Pascal flow outlet boundary condition from the right side of the heads-up display. Let's repeat the process for other vent outlets too. Let's do the same for the back of the cabin. There is one more alternative way to set up the physics. Click on the heads on your screen to open the heads-up display or HUD. Here in this HUD, you have many shortcut buttons like modeling, selection, and physics. You can use hex to quickly access these tools. Here I am going in physics and then fluids and selecting flow and then applying pressure outlet boundary condition. In the last video, we learned how to apply fluid flow physics conditions. In this video, we will discuss Machine Discovery experiment. Here we use a voxel-based meshing approach to discretize the whole geometry. This approach eliminates the need for time-consuming mesh generation as the process is fully automated. The discretization techniques and solution algorithms are designed to achieve maximum automation and speed. Now that we know how we are discretizing the geometry, let's have a look at the meshing tools in Discovery Explore mode to get a better understanding of whether we are capturing enough geometry or not. We have two tools to give you all the insights related to meshing in Discovery Explore mode. The first one is your resolution. It shows your under-resolved geometry in red color, which simply means that you are not perfectly capturing geometry in those highlighted areas in red. To change the fidelity, you can increase or decrease the fidelity by sliding the slider bar on the bottom center of your screen. If you are going to the left, then you are decreasing your fidelity, which will cause an increase in your voxel size. Here, as you can see, when I am going extreme left, I have more under-resolved areas highlighted in red, and as I am going to extreme right, we are getting well-resolved geometry and limited red areas due to the decrease in voxel size. The other tool is your size preview tool, which shows the size of a mesh or voxel element. It is important to note that the mesh element size must be smaller than the smallest feature in the geometry to correctly capture it. Voxel size can also be seen here in the slider bar when you hover your mouse cursor over it. Since we have already set up our fixed condition and reviewed our fidelity, we are ready to solve. Let's run a baseline simulation, and based on the results, we will see what modifications can be made to the model. Since we are in explore mode, the moment I hit the solve button, the solution will start showing the results in almost real time. Let the solution run, and I will meet you all in the next lesson and talk about some post-processing tools in Discovery.